In this example, we have an application of an exponential function. And this one, is very closely related. If I'm not mistaken, it is radioactive decay in terms of half-life. So it says the decay of 405 milligrams of an isotope is given by the following function, a of t, where t is time in years, since the initial amount of 405 milligrams was present. It says find the amount to the nearest milligram left after 7 years. So right here, it's no surprise that 405 is, if you think about the finance side, this is the present value and this is the future value. In this case, we know that it's decaying, so an answer that would make sense to us would have to be smaller than 405 milligrams. So think about reasonableness and sensibleness of your answer when you come to a conclusion after that. Okay, so now let's think about this. If we plug in 7, because they say time t is in years and they give us 7 years, well, if we plug in 7, well, we have our answer. And that's actually exactly what happens. Okay, so let's write out what we have, and I think the problem is probably more wordier than it needs to be. But here it is, e to the negative 0.024 t. So that's the function, and we are looking for where t equals 7. Okay, and so we get something that looks like this. Okay, and now if you have your calculator handy, it's just a very quick calculation. This right here is the base e. It is the base, of course, of the natural logarithm, which maybe you haven't discussed logarithms yet, but you'll find out later. But this is base e. It is known as Euler's number. I encourage you to look up Euler and look up more about this. It's actually really interesting, and Euler was a very interesting guy as well. So we plug it in our calculator and we get 342 milligrams, because it says round to the nearest milligram. So 342 milligrams of this isotope are left after 7 years. So like I said, very, very connected. This is, a loaded chemistry question. That's exactly what it is. If you've ever talked about radioactive decay in a chemistry class, this is what's going on there, and it's really nice to see how it's modeled by an exponential function in a math class.